What are vector databases? Let's begin with the core idea. A vector database is a system that retrieves information based on meaning, not exact words. Instead of matching literal text, it stores dense embeddings that capture intent and context, almost like placing ideas on a semantic map. A strong interview answer is, vector databases let you search by meaning, which dramatically improves relevance. Think about how Spotify finds songs with a similar vibe, or how Airbnb surfaces listings that feel similar, not just listings with the same keywords. Banks use this to detect fraud rings that behave similarly even when the details differ. Patent teams rely on it to find conceptually related filings that use completely different language. Companies love this because better retrieval boosts accuracy, trust, and user engagement. Once you see vector search as moving from literal lookup to cognitive retrieval, the whole concept becomes much clearer. And don't worry if this feels new at first. It becomes intuitive quickly. How vector databases work? Here's a clean way to explain the workflow in an interview. Everything starts with embedding models that turn text, images, or audio into vectors, which are simply numbers that capture meaning. You can picture it as compressing a whole paragraph into a single coordinate on a meaning map. To search billions of vectors quickly, the system uses indexes like HNSW or the IVF index, which act like intelligent roadmaps that route your query toward the most promising regions. When a user sends a query, it's embedded the same way, and Similarity search compares how close the two vectors are using cosine similarity or Euclidean distance. A polished interview line is, all we are doing is measuring how closely two pieces of content align in meaning. Cybersecurity teams use this to detect clusters of suspicious activity. Genomics platforms use it to find similar genetic sequences that accelerate drug discovery. Once you see vectors as coordinates of meaning, the workflow becomes much easier to grasp. Popular vector database solutions. A strong senior-level answer compares these tools through engineering judgment. Pinecone works best when teams want a managed service, with scaling, monitoring, and replication handled automatically. It's perfect for startups and fast-moving product teams. FAISS, the open-source library from Meta, is designed for raw performance and full control, especially when using grams PU acceleration. That's why it powers retail media systems that match ads to user intent in milliseconds. Weaviate is great for teams that want hybrid search or multimodal retrieval, such as supply chain systems that index both structured metadata and semantic vectors. Thanks for listening. A crisp interview answer is Pinecone for velocity, FAISS for performance engineering, Weaviate for flexible orchestration. Think of them as three styles of engineering: managed cloud, performance tuning, and modular open source. Knowing these trade-offs shows strong architecture maturity. Real-world AI pipeline integration. Let's walk through the pipeline the way platform teams describe it. Data from documents, logs, images, or conversations flows into pre-processing, and then into embedding models, like BERT or the ones from OpenAI. These embeddings are stored in the vector database, ready for fast semantic lookup. When a query arrives, it's embedded, compared against the index, and the best matches are passed to an LLM. These are some deep. That grounding step gives you accurate, context-aware responses. A helpful analogy is a librarian who understands topics and themes, not just book titles. Insurance companies use this pattern to retrieve similar claims and detect fraud. Hospitals embed radiology images to instantly retrieve scans that look similar, supporting diagnosis. For businesses, this reduces hallucinations, improves retrieval precision, and speeds up decision-making. Once you see this pipeline as a retrieval and generation loop, the architecture feels natural and predictable. Interview follow-up questions to expect. Senior interviewers often check whether you understand the deeper operational trade-offs. A clear comparison is: traditional databases match exact values. Vector databases retrieve by semantic distance. When asked about embedding models, explain they are neural encoders that convert content into meaning-rich vectors, and that retrieval quality depends heavily on embedding quality. When ANN search comes up, say it trades a bit of accuracy for major speed gains, which is essential when searching millions or billions of items. Embedding drift is another common topic. Meanings shift as data evolves, so teams track retrieval quality, monitor distribution changes, and retrain embeddings periodically. Compliance teams use hybrid search to retrieve precise clauses and semantically similar interpretations across massive regulatory corpora. Support teams track drift to ensure bots understand changing customer language. These crisp, confident explanations signal to interviewers that you understand both the engineering and the operational impact. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.